Okay, so from yesterday, right? Grade 12 here, physics. We got a 2.5 kilogram crate being pushed horizontally with a force of 30 newtons.
Yeah.
And there's a coefficient of friction, but the force itself is sideways, right? And as I met now, here maybe you should include the vertical. This is the weight force. This is the normal force, yes, there's going to be more. And there is friction because we have a coefficient of friction. But is the thing accelerating? It says calculate the acceleration. I guess it could possibly be 0, right? We don't know. But usually if they say calculate the acceleration, there's going to be some numerical value. And we have that this is 30 newtons. That's our FA. And the mass here is 2.5 kilos. Okay. So to find the acceleration, we need to find the net force, right? The horizontal acceleration, we're going to need to find the net force. The net force means add up all the forces. Well, it's going to be a horizontal acceleration, so we need to add up all the horizontal forces. So I have my FA, but I don't have my FF. But I remember from last year that mu equals FF over Fn. And Fn equals Fw, so that means I got to start with exactly. Fw equals Mg. Do you see how I kind of walked you backwards there where it starts? That's kind of a strategy you can use. So 2.5 times 9.8. What's that number? It is okay. We can go with negative. What is it, Brad? That sounds about right. Negative 24.5. And remember, the negative just indicates that it is
down.
Right. So technically, because FF or mu equals FF over Fn, if the FW is 24.5, that means that the Fn is
24.5.
positive 24.5. How come? Because it's
Opposite.
because it's up. Right? Right? Okay, so now I can go.
So why couldn't you just put an N in there and just type negative instead?
How do you write your
Say again?
Like when you put FW equals mass times
Yep.
gravity, couldn't you just put Fn equals mass times
Sure.
gravity?
Yeah. Now that isn't all. You got to be careful because that's not all the time. Because there might be a vertical component of the force that will reduce that, right? So you do have to be careful with that. In this case, the FW and the Fn are equal to each other. But if this is like that, then that changes.
But when it's horizontal, then it's back.
Right. Okay. So now my mu value was 0.2. Solve for FF. Fn is 24.5, and so my FF is 0.2, 4.9? 4.9 newtons. Now I got my FF. Now I can go F net is equal to the applied force plus the friction force. So 30 minus 4.9. Now notice here that I have to actually put the negative on the 4.9.
So could you just not leave it as negative?
Well, I guess, but you wouldn't really be correct.
You are correct.
I probably wouldn't notice it. But you wouldn't actually be technically correct. So that's going to be 30 minus 5 is going to be 25. So that's going to be 25.1, I think, right? Right, Jeff? 25.1? Okay, now what? F net equals MA. 25.1 is equal to the mass 2.5A, which gives you an A. I think it's 10.04. That one's not too bad at all, really, is it? Just a reminder about that mu thing. Now what? Oh, there's more to it? How far does it move after 4 seconds? Okay, so now we're past dynamics. We're into like the same stuff we did last unit. How far? So I've got the A. I have the VI.
And you have time.
I have time. So I could use, yes, D equals VIT plus 1/2 AT squared. I noticed when I was marking the first part of the test, I have about 3 questions left. Some of you aren't using the grade 12 formulas. You're still relying on those old grade 11 ones, and it's making your steps really, really, really long. So stop that. They'll be done for tomorrow.
Yeah, but don't you?
Well, if we're not here tomorrow, we're gonna play.
You come by and see me in the morning. I'll probably come.
Yes.
Yeah, or certainly at noon. No, I'm not here tomorrow afternoon. No, so I'm going with football guys. Yeah.
So I have to put on a video?
Will have the,
Yeah, I'll have the sub hand them out.
do we have to have them back?
No, I think everyone's written. Yeah. That, like, I know I have, because I've called in a sub for the whole afternoon, so I'm actually going to take, football guys, I'm actually going to take the first half hour of my period 4 class before we leave to finish them up. So I could even bring them with me if you want. Want to do that?
Do it
Okay.
Procedures, I just want to know what content
Yeah.
is for the class.
Okay. Josh?
I just missed that part where you got 8.
Just 25.1 equals 2.58? You're just dividing by 2.5? This is just to plug in the number here, right? So what is that? Half of 10 is 5 times 16, 80? 80 meters?
23.
Whatever. Sorry, must have added up. Okay, so now these are some more challenging grade 11 problems that you can use as practice to get us going. Normally what I do is, I do this next set of notes. I don't know how necessary it is, so let's just whip through it really quick and see. Let me just explore. All right, well, enough fun and games now. Okay, so let's talk about the net force. Remember, normally I would sort of do this. This should actually be what I started talking about yesterday first. You kind of do it, Josh. I don't know. Do you need to? I don't think so. This is just a reminder about what net force is. So in the expression F equals ma, the A can be interpreted as the total resultant acceleration which a body receives when acted upon by some total force whose magnitude and direction are given by F. So what I'm really saying there, I'm translating it, F equals ma is really F net is equal to ma, right? Because the acceleration is because of the sum of all the forces, right? Like the total result of all the forces, which we call the F net. F net simply means what? Add up all the forces. Now sometimes you might have F net x, which just means the x component, just the sideways, right? Because there is no up and down movement, right? Okay, so here I said since force is a vector quantity, the total force acting upon an object is the vector sum of the separate forces they're acting. It is usually called the net force. Now, is this actually a sort of a formula?
Sure.
Not really. It's just it's a statement. The net force is force 1 plus force 2 plus force 3. All the forces added together. That's all that really is, right? It's not really a formula that you're going to need or use. Okay, so, for example, two young boys, Johnny and Billy, they're bad, playing tug of war. Each is pulling with 75 newtons. They're pretty strong little kids. One is 75 to the right, one is 75 to the left. The net force is 0, right? 75 minus 75. That's quite a bit. That's like, well, like, I weigh like about 700. I mean 800.
Can you take that and did we do something last year where you had the weight in newtons and then you had to put it into?
Yeah. Well, how do you get from newtons to kilograms?
I don't know.
Divide by 9.8.
Oh.
Right?
Let's go weigh myself.
You can weigh yourself later. Okay, so here now, is this object moving?
No.
Josh says no, Jeff says no.
It's not moving.
Brett says no. Not moving down yet.
Not side to side, please.
EJ, what say you? Is the object moving?
Are they in a vehicle?
Ah! Maybe they're on the back of a flatbed truck playing tug of war.
Exactly.
Oh.
Oh my goodness.
I did crack my screen. Well, they're
Here's no safety.
Billy and Johnny. They do whatever they want.
They do, they're rebels, right? Maybe they're on like a parade float and they're, fighting over candy or something. That could happen.
It's just like tug of war.
Actually, the answer is, it depends on what they were already doing. Because if the net force is 0 and you're already moving, what do?
Staying at that motion.
You would stay at that speed, exactly. So yes, it's quite likely that two young boys playing tug of war on the ground are probably not moving. But that said, if you've got two forces that are equal and opposite, that doesn't necessarily mean that it is not moving. It really just means, if the F net is 0, what that really means is the acceleration is also 0, does it not? So it could actually be moving. Could be. Okay, now this time they're working together for some reason. You would go 75 plus 75 and you get a total net force of 150, right? You see how this is simpler than what we did yesterday? Yeah. Like I probably shouldn't start with this and then work into those questions from yesterday, right? I just haven't had a chance to put that together. Okay. Now in real situations, friction is often a force that reduces the net force, right? This results in the formula F net equals Fa plus Ff. But really, this is no different than F net is equal to F1 plus F2, really, right? It's just the adding more and more forces. It's just that these ones, we use this one so much that we tend to sort of consider it a formula. And recall that FF, like all forces, is a vector, so it being in the opposite direction will have a negative sign associated with it, right? The FF should be negative, but let's write it as add because we're really adding vectors. Can you do this one? Do you need to write it down? Let me just look and see how many examples I got. I got 1, 2, 3.
Let's write them.
Nice idea. God.
Maybe I should say,
Was there no high resolution? No.
It's the net force.
yeah, it's not exactly HD quality, is it?
Is there no high resolution picture? So
That was like HD back then.
That's right. I remember going to see Star Wars for the first time. 1977 in
My mother was
Wyoming.
And how was that?
It was awesome.
Was it?
In Wyoming?
In Wyoming, we were, Yellowstone Park. We were there. I remember we went. There was two options.
Did you clap after?
I don't know. I just remember standing around outside and going.
Clap afterwards.
My mom and dad asking after how was it. It was awesome.
Good show. Good show. Some passionate fans clap after.
Oh yeah. Okay, give this one a try. I'm gonna do my attendance.
Look at the
10 kilogram object accelerated by a 10 newton force. Oh, this is easy.
It's 1.
Force of friction is 6, so all you're doing is going F net is Fa plus Ff. That's going to be 10 minus 6, right? The F net is 4, right?
What if you go FF plus FA?
Because friction.
You can, sure. I mean, so then you got minus 6 plus 10.
Yeah.
It's weird, but I'll take it.
Okay.
So it's the same answer.
Yeah.
Exactly.
0.4?
Yeah.
Yeah, that was easy.
Do you have to put units? Like,
You should put units on your final answer, yes. You should. Like if I came over and said, Danielle, how would you like 15? And you'd say,
15 to 1.
I might say smacks in the head. Not so good. If I said dollars, you'd say sure, right? Units are important.
I would have picked the smack in the head.
You know I'm not going to smack anyone in the head.
Can I get $15?
I'll try this one. This one's asking for the force of friction. So we're solving for it. Yeah, I apologize.
oh, I should be writing.
Oh, yeah.
No, I like.
Okay, so we got a 3 kilogram object moving 5 meters per second at t is equal to 0. 4 seconds later, it's traveling at 2, so it's actually doing what?
Decreasing.
Slowing down, right? We need to find the force of friction that is acting. So what do I know? I know the mass. I know I guess that would be the initial velocity, right? And then the other one would be the final velocity. And the t is equal to 0 is kind of doesn't really matter. but the time is 4 seconds, I think, right, Kasia? So you're looking for FF. Now the only real formula that I have so far that's got F in it, or FF in it, is the F net equals FA plus FF, right? But there's only, hold on here, let me just draw the picture. What's going on here? I got weight force, normal force, there's no vertical. I think the only force that's acting is what, Talia? The only force that's acting is the friction force, right? So in other words, the F net equals the FF, right? Is that what we're getting out of that? I think so. So F net equals MA. So I gotta find F. I gotta find the A.
Because it's,
There's nothing pushing.
There's nothing pushing it. It just says what force of friction. It's just slowing down, right? So something rolling down the hall, slowing down. So I think you're right. I think we got to find the A, right? So what do I know? I can use this one. VF equals VI plus AT. The final is 2. The initial is 5. We're going to solve for A. Our time is 4. Now I have noticed, I can't remember whether it was you guys or my other class, my grade 11s, there's still some solving equation issues with some people. I can't remember whether it's you guys or my other guys, but you need to be able to solve this now, like without even sort of thinking. You should know that A equals, the 5 goes to the other side, it's going to be 2 minus 5, and then we're going to divide by 4. You got to be able to do that now. Minus 0.75.
Yay.
Right? And now we're going to use that in,
so because this is his final answer, we don't, if you,
I mean, you can if you want. I just don't check them in the meeting, that's all.
okay.
It's not that you don't need it, it's that I don't check them. F net is equal to MA. The mass is 3. The acceleration is minus 0.7. Now, does it have to be negative? It's slowing down. It's to the left, right? So that's going to be 3 times 3/4 is 9/4, which is 2.25, right? Sometimes I ask questions that I know the answer to, bro. I ask them because I want you to ask them of yourself.
Pretty dumb.
That's what teachers do.
That's silly.
That's called good teaching. Does your dad ever talk to himself when he's working on something?
You're going to this story like you have.
Yeah. You know why dads do that?
Do you remember like you
Get
figured-
expert advice.
It's because they're doing what I just did, asking questions that they aren't. So you say it out loud and you answer, and it just helps you think.
It's not.
once you hear it out loud?
Yeah. How many times have you called the teacher over, asked the question out loud, and they're like, "Oh, now I get it."
A lot of times.
Why? Because you're asking it out loud. Exactly.
Oh, come on, man. That's why you guys don't have to repeat the questions to you?
Yep.
God knows for that.
And if you like,
Why do we do it?
Hey, we didn't. Oh,
Okay. Yeah.
could I get all your tests on audiobook?
Yeah. On Audible, the friction force then is minus 2.25 newtons, right?
So I could like put
It's
that.
actually right.
The force is at an angle. So we got a force of 50 newtons applied to a 10-kilogram sled at a 30 degree above horizontal. The force of friction is 18. Find FAX. So that is this one right here. And the FAX is adjacent to the 30, right? So it's going to be cos. So FAX is going to be FA cos theta, or 50 cos 30, right? What'd you get, Jeff?
I don't know, my cooking.
Well, you should figure that out before the test, don't you? Right? So let's try it right now. You're going to go 50 times, I go 50 times 30 cos equals 43.3. Yeah? Okay. So now what's the F net?
Yeah, stuff like that.
Yeah. Right? The F net is the horizontal F net. So F net, oh, this isn't that bad at all. FAX plus FF. So this is going to be that 43.3 minus 18. Right, so subtract 18. Right, Josh? 25.3?
Yeah.
And now we're just going to go, oh, I thought this was going to be longer. 25.3 is equal to 10a. How do you solve that? Divide by both sides by 10. 2.53 meters per second squared. Not that hard at all. All right. So I provided you with two different sets of problems. There's the Star Wars ones today that I would say would be,
Oh, like, grade 11.
yeah, the first one I actually handed to you in grade 11. I just retitled it. But they were kind of challenging questions, right? This one here is what I've handed out for years and years and years. There are some here where the forces are at an angle, so you're going to have to add like components and stuff like that, right? There's a QR code. Oh, I'm all excited because last night I updated my iOS.
Really quickly.
I updated my iOS last night and I didn't have a QR code at home and I was so disappointed. All I do
Does
is,
it work now?
no, all I do is use my camera, right?
I told you that. You want to show me?
It digs at the top. It's really quick.
It doesn't even go beep.
I wish it'd be.
Yeah, I kind of wish it would be too. The other one would have like a little square, you know, kind of like a target. Sweet. Update your iOS. Yeah, you want to
Get right on it.
yeah, you can really try.
Let me get right on that island.
Okay, I'm gonna be quiet. You guys work on these. Same thing tomorrow. Monday, I'm gonna start powering through. I gotta do.
Do you recommend us to maybe
You took my sheet.
I would recommend probably doing this one first.
So, now tomorrow we're working on these.
Yep.
Here.
I gotta do we're gonna do inclined planes on Tuesday. Ramps.
Does it make a difference?
Like, that's